Hi everyone, in this video we're going to go over another Leetcode question, palindrome number. Major tech companies like Google, Facebook, Microsoft, LinkedIn are asking this question while they're conducting their technical interviews. I hope you will find this video tutorial helpful for your technical interview preparation. Let's start with reading the question. Determine whether an integer is a palindrome. An integer is a palindrome when it reads the same backward as forward. Example 1. 121 is a palindrome, reads the same backward and forward. Example 2, minus 121 is not equal to 121 minus, and it is negative numbers are not palindromes because they don't read the same. And 10 false becomes 01, so it's not a palindrome, so we return false. Could you solve without converting the integer to a string? That's the question. Let's get on the whiteboard and try to solve this question. So to solve this question, we need to reverse the integer. Okay, so when we reverse the integer, if it's the same as the integer in the beginning, then we say there's a palindrome. I recorded a reverse integer video. You may want to have a look at that one as well to understand better, but I will try to show here again. So what we do here is we need to pop these digits one by one and push it to the new reverse digit we create. While x is greater than reverse. For now, let's think x is greater than 0 for this number, okay? Just for 1 second, we need to think that way. So, x is reverse is 0. Reverse times 10 is 0. X modulo 10 is 1. So, reverse is 1. And divide x by 10 and it's 12, right? Reverse is, now 1 times 10 is 10. And 12 modulo 10 is 2. 10 plus 2, 12. My new reverse is 12, right? And x is 12 divided by 10 is 1. And reverse is reverse times 12 times 10, 110. 1 modulo 10 is 1. And that will be 121. This is how we reverse a string. So when we reverse an integer. When we reverse this number, it should be the same. Then in that case, it means it is a palindrome. Okay, that is the idea. So the first thing we check is we need to ignore all the negative numbers. Okay, negative numbers are not palindromes. X is not equal to 0, and if the last number is 0, if x modulo 10 is 0, then that means last number is 0, so it will be the 0 will be in the beginning, so it can't be a palindrome either. So if the last number is 0, we can't have a palindrome there either, and we return false in that case. Excuse me. So what is the idea? What's the deal with x greater than reverse? So this is for if you have integer overflows like large numbers, then we can't go all the way to the full string, right? We can get an integer overflow error if we have the full strings. To overcome that, what we do is we go until the half of the integer. Okay, for example, this is our integer 345543, right? The first pass, our reverse is 3, right? The reverse is 0 times 10, 0. X modulo 10 is 3, so that is 3. And our input is 34554. And input is as in x. We can say x here, that's better. Sorry. X is then this is our x. So our new x should be equal to reverse, and x should be equals to or equal to reverse divided by 10. I will explain this one in a minute as well. So second pass, the second iteration, this time I got 34, right? 3 plus, then 4 comes, then we push the next digit, and x becomes 34554, right? 34554, yes. Sorry, it should be actually this. If we push the 4, yeah. And we continue. Because x is still greater than reverse. And we continue. And the third pass, we push 5 onto it. And x is still 345. And when we see this, we have these two numbers equal. X is not greater than reverse anymore. So we are breaking the while loop here, because to have the while loop, they have to be, x should be greater than reverse, right? So in the first example, I use x is greater than 0, so you understand. But it is not 0. We only go until the half of the string, half of the integer, sorry. So in this case, 345 is 345. Then x is greater than reverse returns false. So this loop breaks. Then we return, is x equal to reverse? In this case, yes. So we return true. This is a palindrome. So we only go until the first half, right? And we only reverse the second half. That's what we do. Then we say we only go until this half. Sorry, we only push this half in reverse and compare two integers. That is the idea here. So what is the deal with reverse divided by 10? If we have a number like this, 7 here, then we will have one more number here. So in that case, we use reverse divided by 10. Okay? So because this is odd number, for odd numbers we need to make sure the x and reverse is same, and the way to do is we need to divide by 10, and that will give us the odd number. So that is the idea here, right? So let's see this in the code and submit. Okay, so this is the code here. Let's submit and see. Okay, this works. So this is, yeah, for example, just need to, this is ON time complexity, by the way. Just a, this is, for example, an integer, the maximum integer number. When you reverse this, if you see this 8 comes to the beginning and 4 comes to the next, etc., that number is causes integer overflow. So to avoid that, we only go until the half of the integer. So we are not going any above the half. I mean, we only keep the half of the integer. So this way we overcome integer overflows. I hope it was helpful and I tried to explain it. I have more videos coming up, so if you subscribe to my channel, we can meet again later. Thanks for watching. Goodbye.